All right, guys, welcome to your e-learning day for ICP. Hopefully this video works. This is my second take. Apparently my camera was closed the entire time. I recorded this last time. So today we're going to go through your study guide. We're going to hit a few things from the study guide, not everything. After we do that, you need to make sure you answer those 10 questions on Canvas. It should be titled Unit 3 or 930 Unit 3 Study Guide Check. So make sure that you go in and do that. It's going to take some questions from the study guide and give you a chance to check to make sure your answer is correct on that. For today, we're going to start on the back side and work our way towards the front, basically because I have a drawing I want for the back page already on the board. We're going to start with number 55. Number 55 is asking, what element is all life on Earth based on? Well, all life on Earth is based on a single element, carbon. Carbon is the basis of all life on Earth. That's why sometimes you will hear that we are called carbon-based life forms. All right, so that's number 55. Takes us up to number 51. For number 51, I just want to talk about the special family names of the periodic table. So up here we have this beautiful drawing of a periodic table. Some of these families or columns have special names to them. For example, family 1, these are the alkali metals. They have 1 valence electron. Family 2, those are the alkaline earth metals with 2 valence electrons. Then we have the transition metals here. We come to the boron family with 3 valence electrons. Then we have the carbon family, which has 4 valence electrons. And then we have the nitrogen family with nitrogen at the top, which has 5 valence electrons. Then oxygen, the one with oxygen on top, that is the oxygen family. They have 6 valence electrons. Then the halogens, which are family 17. The halogens have 7 valence electrons. And then the noble gases in the very last family, those have 8 valence electrons. Now keep in mind, family 1 is very reactive and will react violently with water. Family 17 is also very reactive and will react quickly with metals. Family 18, the noble gases, are unreactive and won't really react with anything. That takes us up to 49. On 49, I'm just going to go through that list and say what each of those classifications these elements have. So on 49A, lithium is a metal, silicone is a metalloid, iodine is a nonmetal, oxygen is a nonmetal, titanium is a metal, and Sb, which is antimony, that is a metalloid. So you should have 2 metals, 2 nonmetals, and 2 metalloids for number 49. All right, if we jump up to number 41, which elements would have similar properties to argon? Now remember, elements that are in the same family are going to have similar properties. So elements that are above and below each other, they're going to have similar properties. Now argon, if you find argon, is about right here on the periodic table. It's in that last family, the noble gases. So elements that are going to have similar properties are going to be in that same family and part of the noble gases. So that could include helium, neon, krypton, xenon, and or radon. All of those are going to have similar properties to argon. The next question is, what element is in column 6, row 7? Remember, the columns are the up and down formations. There are 18 columns. So if we come over to column 6, which is about right here, that has Cr at the top, and then No, and then tungsten, and then it has Sg at the bottom. So this is the column that we are looking at, column 6. Now we're also trying to find the element in row 7. Now remember, rows go sideways. So we have row 1 here, and it comes down to row 7 at the bottom. There are a total of 7 rows on the periodic table. So if we're looking at column 6 and row 7, where those intersect is going to be right here at Sg. And so for number 38, what element is in column 6, row 7? We would say Sg. All right, now if we jump up to 21, or actually 25. So the electron cloud model. So the electron cloud model is one of the models of the atom, and it's just like a cloud surrounding the nucleus. in that model, that cloud represents a couple of things. Number one, it represents possible locations of electrons. So those electrons can exist in anywhere inside that electron cloud. The second thing it represents is all possible orbitals for that particular atom. So those are the two things that the electron cloud represents. Now, if we jump up to 21 through 24, I'm going to kind of go through all those together. So for 21 through 24, we're looking at an electron and how it changes energy levels. So we have this electron that exists, let's say exists at that energy level right there. It can either increase energy levels or decrease energy levels. Now, to do that, it has to do one of two things. It has to either absorb energy or it has to emit energy. Now, if it's going to increase energy levels, that means it's going to absorb energy. And that way, as it absorbs, it's gaining more, so it's going to a higher energy level. Now, if it goes down, it's going to emit energy, or in other words, lose energy or give away energy. And so it's going to decrease energy levels. Now, when we look at these two possible methods, only one of those has a chance of producing light or giving off light. And that is going to be when the electron emits energy and decreases energy levels. When that happens in certain atoms, certain elements, it is possible that you would get visible light being emitted and would be able to see the light itself. All right, so that's 21 through 24. It takes us up to number 18. Number 18 is asking how many protons, neutrons, and electrons chlorine 37 has. Well, the first thing you need to do is find chlorine on the periodic table. And if you find it, it's number 17. Now, because it is number 17, that means there are 17 protons and 17 electrons. Neutron-wise, we need to use the mass. Now, a lot of you guys like to use the mass 35 minus 17 protons. You only do that if the mass number is not given to you in the problem. For example, on problem number 17, there's no mass given to you, so you take the mass from the periodic table, 35, minus the number of protons, 17. But in number 18, it's called chlorine 37, which means the mass number was given to you. So you take the mass number 37, subtract the protons, so 37 minus 17, and that gives you 20 neutrons. So the answer to 18 is 17 protons, 20 neutrons, 17 electrons. We'll jump up to number 14 on the study guide. Number 14 is asking what is an isotope. An isotope is going to be two atoms of the same element with a different mass. All right, so for example, we could have chlorine 37 or we could have chlorine 35. Both of these are chlorine atoms, but they have different masses. A mass of 37 and a mass of 35. So those would be considered isotopes of chlorine. All right, flip to the front page of the study guide. We're going to look at number 12. So number 12 is asking how many protons, electrons, and neutrons does the atom to the right have? All right, so let me draw that out real quick. So we have calcium 42. So this is our isotopic notation, and it's asking how many protons, electrons, and neutrons. This bottom number here is the atomic number, or in other words, the protons. So we're going to say it's 20 protons, therefore it also has 20 electrons. To find neutrons, you take the mass number minus the protons, so 42 minus 20 gives us 22 neutrons. So that's number 12. Takes us to number 5. Number 5, I'm just going to focus on the location of those particles. So we already know protons positive, electrons negative, and neutrons neutral, or in other words, zero charge. But the protons and neutrons are located in the nucleus of the atom, whereas the electrons located outside the nucleus, or in other words, in the electron cloud of the atom. All right, moving on to the last problem I'm going to cover, number 1. Number 1 is based on historically people's model of the atom, and we have 5 old dead people. The first one is Aristotle. I like to call him Avatar Aristotle because he didn't actually believe in the atom, but instead thought everything was earth, fire, air, and water. He thought those combined together made everything. Now, he was a Greek dude. The other Greek dude was Democritus. Democritus actually thought that atoms existed, but most people didn't believe him back then, and so he wasn't able to achieve much with that idea. Fast forward hundreds and hundreds of years, and you get to John Dalton. John Dalton thought the atom was a small solid sphere, so basically like a solid golf ball type deal. J.J. Thomson came along later, and he discovered the electron within the atom, and so he said that the atom was a positively charged sphere that had bits and pieces of negative electrons mixed in. In other words, it was like a cookie or a chocolate chip cookie dough model. If you take a chocolate chip cookie dough and you roll it into a ball, that would be basically J.J. Thomson's model. You have the positive sphere, and then you have those bits and pieces of electrons mixed in, which would be like the chocolate chips. A little bit later, after Thomson, Ernest Rutherford did his gold foil experiment. In that gold foil experiment, Rutherford discovered that the atom is mostly empty space, but he also discovered that the atom had a nucleus which was very dense and positively charged, located in the center of the atom. All right, so anyways, those are the parts of the study guide I'm going to cover. Make sure you go onto the study guide, check on Canvas, and do that assignment. It's going to ask 10 questions from the study guide. Make sure that you got those answers correct. If you have questions, please send me an email, and I will try to respond to those. If you make sure you bring your study guide tomorrow as well, because after the test, you will need to turn it in. I will answer any questions you have before the test starts, though. So anyways, that is all for today. Like I said, if you have questions, please send me an email.